So let's leave all of those, okay? We haven't done normal. All right, fast food outlets, 60% of orders are placed at drive-through counter include chips. It can be assumed that an order placed by one drive-through customer is independent of any other. Okay, so out of the next 3 orders placed at drive-through, at least 2 will include chips. All right, so we have 3 orders, so N is 3, probability of success is 0.6, all right, and they're independent. What's the probability that at least 2? So the probability that x is greater than or equal to 2 is equal to probability that x is equal to 2 or x is equal to 3. Since x is distributed binomially with 3 trials and instead of 0.6, I'm going to put 3/5. Okay, so then we're going to say we have 3 trials, 2 successes, and we've got 3/5 to the 2 times 1/5, 2/5 to the 1, plus 3 successes, which is 3/3, 3/5 to the 3, 2/5 to the 0, which is equal to 3C2 is 3 by 3 on 5 squared is 9 on 25 times 2 on 5 plus 333 is 1. 3 on 5 cubed is 3 to the 3, which is 27 on 5 to the 5, which is 125 times 1. So I'm going to get 3 2s are 6, 6 9s are 54. 54 on 125 plus 27 on 125, which is equal to 81 on 125. Okay. How many orders would need have been placed at the drive-through counter if the probability that at least one order included was equal to 0.84? So this becomes a calculator one, doesn't it? So we've got our calculator. For 3 marks, I can't just go to a calculator and put an answer. So let's just see how well we can do here without a CAS. That might fall out. So I need the probability that x is greater than or equal to 1 is equal to 0.84, all right, which means 1 minus the probability that x is equal to 0 is equal to 0.84. So the probability that x is equal to 0 has to equal 0.16. What is the probability that x is equal to 0? Well, we have 3 choose 0. Probability of success is 3/5 times 2/5 to the 3. Oh, we need n, sorry. So we don't know if we've got 3 trials. So let's just get rid of the 3. So instead I've got, I'll just put an n there to make it obvious. So that's still 0, and I'm going to have n failures. All right. So that implies that 2 on 5 to the n has to equal 0.16. So I'll put 16 on 100. Nah, not going to be very nice. And what's 16 on 100? 8 on 50, 4 on 25, isn't it? 4 on 25. Oh, it works out for us, doesn't it? Look at that. So that implies that 2/5 to the n has to equal 2 on 5 squared. If I simplify that, that implies that n is equal to 2. So clearly it is a tech-free. All right, but again, it's one of those ones where you have to know your binomial distribution, the law for it. All right.